This is our lesson on linear systems, and systems just means, in this case, more than one. So we're talking about more than one line. Lines can intersect in three ways. So we could have one point of intersection, and a little quick sketch of what that might look like. If I just draw, say, a line here, and then another one here. Whoops, I shouldn't have drawn a vertical one, but that's okay, it doesn't matter. They cross once, and if you imagine then these lines all continuing on to infinity in each direction, they're never going to cross again. Even though they go on to infinity, they will never cross again. They have different slopes, therefore the graphs will cross paths once because the slopes aren't the same, so they're going to intersect once. So sample equation would be y equals 2x plus 1 and y equals negative 2x plus 1. Those equations don't match the graphs I just gave you, but the point is the slopes are different, so they're going to cross once. Now what about if we have 0 points of intersection? How could that be? Is it possible for two lines to never ever cross each other? It is if I draw them like this. So here's one line. How could I draw another line that would never ever cross that line? If I drew a line like this, if I could draw them parallel, which I didn't do perfectly, but if the slopes are the same, but we have different b values, different y-intercepts, therefore the graph will never cross. So here's a y-intercept of 1, my other y-intercept would be down here somewhere, so the y-intercepts are different, and that's fine, but the slopes are the same. Y equals, let's do the same one I put above, 2x plus 1. Let's say that's my top graph, and then y equals 2x minus 1. The slopes are the same, so they're parallel, so they're never going to cross. Now the last one is infinite. Infinite points of intersection. That's kind of a weird one. That means if I draw a line here, and I want to draw another line that's going to cross it an infinite number of times. So I'll use a different color just so that you can see. If I draw a line right on top of it, that's yellow is hard to see, maybe I'll switch it to red. If I drew a line right on top of that dark blue line, those will cross everywhere as they continue on to infinity. So as this one continues on to infinity, it's going to stay on top of the blue line. The equations of the lines are exactly the same, so they're always going to intersect. This is probably the most rare situation that you get in your homework where the two lines are the same. But let's see what that means. Let's say our first line, the first line I drew there, let's say its equation was y equals let's say 3x, well, I should use 2x plus 1. Just use the one I've been using all along. 2x plus 1. Y equals 2x plus 1. And then I have another equation, so let me use red for that. But this equation looks like this. 2x minus y plus 1 equals 0. That's standard form. Those two equations are exactly the same. These two are equal to each other. One's just in slope y-intercept form and the other one is in standard form. So if I took my red equation here and rearranged it, let's say I add y to both sides, I would get 2x plus 1 equals y. That's the same as the top line. So they're exactly the same line because the equations are exactly the same. And sometimes you might have something like, let me put another sample one that would be exactly the same. I could have had just a multiple, right? Like 3y equals 6x plus 3. So I just took this equation and I multiplied everything by 3. That's the same, going to be the same line, because when I go to isolate y here, I'm going to get the same exact equation again. So those are examples of lines that have infinite points of intersection. Example 1. Given these equations, state whether or not the lines will intersect. So now you have to think of what you just wrote down on your sheet there. So how can we tell if they will intersect? First of all, are these two exactly the same? No way. So infinite is not an option here because this line is not the same as this line. So infinite is out of the picture. Are they parallel? So let's look at the slopes. This slope is -3. My second line has a slope of 5. So they're not parallel, which means they're definitely going to cross. So state whether or not the lines will intersect. So yes, they will intersect once. They are going to intersect one time. Part B, find the point of intersection. To do this, I'm giving you little hints here. To do this, we're going to graph the lines on the same grid over here, and we're going to estimate. So we're just going to graph them, and then we're going to look to see if we can figure out where they cross. So how do we graph these lines? This is a good review here for how to graph lines. So I'm going to graph the first one in red. First, I start with the y-intercept. So I'm going to do this first. I'm going to put the y-intercept on as 6. Well, before I do that, I'm going to have to put a scale on my x-axis and my y-axis because I can't just stick dots on there and assume that everybody knows my scale. So I'm going to count by ones, but I'm going to label every second one like this. All right, I just press pause because that's what I do. I press pause and then I write all these things down and then I unpause it. And when you're watching it, it looks like it's going super fast, right? Just press pause and go to the pace that works for you. So I've got my scale on there. I counted by ones, but I labeled every second one. And now I'm going to put on my first equation. I'm going to do this one here in red. So I'm going to start first with my y-intercept of 6. So there's a dot right there on my y-intercept of 6. Now the second thing I work with is the slope. So the second thing I'm going to do is I'm going to count out the slope. And my slope is a -3, which is really -3/1. So that's rise over run, or in this case it's a fall over a run. So I'm going to go over to my intercept of 6. And from that big red dot on the 6, I'm going to drop 3, 1, 2, 3, and I'm going to run 1, always run to the right 1. Put a dot there. Let me just erase these little lines I put in here and put my dot back on there. So I fall 3 and run 1, and I can even do that again. Fall 3, 1, 2, 3, and run 1. Put another dot, so I could keep going, but that's really enough. So now I'm going to draw my straight line. I'm going to try with my ruler. Okay, I've got my line on there. I'm going to put arrows on because certainly this line goes on to infinity in both directions. Now let's look at our second line. I'll use green for that one. Y equals 5x minus 2. So the first thing always is to place the y-intercept. So I go down to -2. There's my y-intercept at -2. Then I have a slope of 5, and that's what I do second. My slope is 5. So that's really 5/1. Now some of you ask me, what if we run to the left? I'm going to put this in here, but I find this confusing, but I'll show you anyway, just because some of you ask me. From this green dot, I could fall 5, 1, 2, 3, 4, 5, and run 1 to the left, and then I would get a dot here. But running left in this case means I'm also going to have to fall instead of rise because they're both negative. So I would stick with rising from here, rise 5, 1, so 1, 2, 3, 4, 5, and running 1. I think that's the easiest way to go, and that's right there on top of that spot. So I wouldn't ever run to the left. I think it just makes it confusing, and then there's too much to remember. So I would always rise and then run to the right, or fall and then run to the right. But anyway, I'm going to connect my dots here with the ruler. So arrows on here, and this is actually a bad example. I should change this example because the question we're working on here, part B, says find the point of intersection. Well, it's pretty clear. It says here estimate their point of intersection, but I could see when I was counting out my rises and my runs, the point of intersection was right here, right? So I don't even really have to estimate because it happened to work out really nicely that I could see where it was. But in any case, that's what you would do. You would take a look at your graph, you'd take a best guess at what that point is, and our estimate of our point of intersection. So POI is short for point of intersection. Point of intersection is, and it looks like it's 1, 3. And it's a pretty good guess, I think, because our lines happen to both use those when we counted out our rise and run. So our point of intersection is 1, 3. Now part C says verify your solution. So lots of times you'll graph it and it won't be as nice as this. So we're going to verify our solution by going, first I'll write down the first equation in red. I'm going to do a t-chart here, and let me just get my ruler and see if it will cooperate with me. Oh, that wasn't too bad. Okay, so over on this side of my equation, my red equation was the y. The equal sign was here. I don't need to put that there. And on the right side, I had negative 3x plus 6. So I'm checking this algebraically. So in for y, this 1 is x, 3 is y. I'm going to put a 3 here. Now negative 3, instead of x, I'm going to substitute in a 1 plus 6. That gives me negative 3 plus 6, which is 3. So that means the point 1, 3 is definitely on this line. Okay, that's all I've proven. I've proven that the coordinate 1, 3, I've just proven that that is on my first line, y equals negative 3x plus 6. That's what I've proven. Now, if I can prove it's on both lines, then it has to be the point of intersection. So think of the logic there. There's no way that this point could be on both lines and not be the point of intersection. So let's do another little check chart here. Left side, right side, check. Yeah, that's my ruler. My pen is really miserable with this thing. Okay, I had a y, so I'm writing this out right here. This is what I'm writing out. On the left side was a y, on the right side was 5x minus 2. I'm going to sub in. Again, here's my x, here's my y. My y is a 3, my x is a 1. That gives me 5 minus 2, which is 3. So since I got left side equals right side for both, you have to check both. If I only check one, then it's only on one line. Since left side equals right side for both equations, and the short form for equations is this, since left side equals right side for both equations, then that means 1, 3 is on both lines. And it must be the point of intersection. So if 1, 3 is on the red line, and 1, 3 is also a coordinate on the green line, then it's got to be the point of intersection. There's nothing else it could be. However, if I substitute it in here, I didn't get left side to equal right side. Now they both happen to equal 3. That's not important. What's important is that this left side equals this right side, and this left side equals this right side. If it only worked on one, then that would mean if it just worked on the red line, then that would mean I found a point on the red line, maybe this one. But if it didn't work out to be on the green line, then it's not the point of intersection because it has to be on both. Example 2. Now this is going to get crowded here, so either get another piece of paper or write small. We've got movies to go, and they stream movies for $2.50 each, and they have no membership fee. Film Streamers charges $2 each, but has a $10 annual membership fee. Write an equation for each situation. So each situation means we've got movies to go and we've got Film Streamers. So what we have to do is take this English stuff here, these words, and we have to translate them into math. So we're going to need some letters, some X's and Y's. So here, think of what you would put down here on the x-axis. I've told you before that anytime you have a question that has per, like if you were walking at, 5 kilometers per hour, well then hour would be this one down here because it's the one that comes after per. So in this case, think of it as $2.50 per movie. That's what the each means. So since we have per movie, that means we can use for our variable M for movies? I'm going to use N actually because N is pretty common. So I'm going to put this up here because I know I don't have a lot of room. Let N represent the number of movies that you stream. I had to write over my grid and I'll have to erase it when I go to graph, but I don't have a lot of room. Okay, so now I want you to think about it. What's the other variable? What's the dependent one going to be? What depends on the number of movies streamed? So don't just sit passively and wait for me to tell you the answer so you can write it down. You should be thinking about it. So pause it and think about it. You're asking yourself, what's the other variable? What's my vertical axis going to be? And it's common in questions like this for it to be cost, and we'll use a capital C, that's standard. So let cost represent, these are ditto marks, that means what was above is below. Let C represent the cost of membership. Cost of membership. And we have another clue in the question here, and the other clue in the question is the word annual. So that means we're not talking about how many movies we stream in a day or in a week or in a month. We're talking about in a year. So cost of membership. And so this whole question we're doing is in 1 year. In 1 year. Okay, so now we have to come up with equations to go with that. So equations are always in the form, let me put it up here, y equals mx plus b. Now we've replaced our y with a c, and we've replaced our x with an n. So what I need to figure out first is the slope, and I'm going to talk about movies to go first. So MTG, movies to go. Let's talk about their equation. They're 250 each. That's your changing number. That's your variable number. That's your number that depends on how many movies you rent. So that's my M value. So cost is capital C, cost equals, and we've got 250, or you can put 2.5, you don't have to put 250, and then X, except we have an N. Now what's our B value? What's our Y intercept for movies to go? Well, they have no membership fee. So this is an example of direct variation. You could put, if you want, a +0 out here. I'm going to erase this in a second. You don't need it because it's a 0. So, but there is no fixed cost. There's no membership fee that you pay once. Now let's look at film streamers. So for film streamers, let me switch colors here. How about red? For film streamers, their cost is equal to, so their price per movie is $2 per movie, number of movies, and they do have an annual membership fee of $10. So there's our two equations. So that's good. Now we have some math going on here. Part B says graph both equations on the same set of axes, and then we'll finish the question later. Let's just start with the first piece. Graph them. We have to graph these. I'm going to have to label my x-axis here. So I'm not going to put an x here, I'm going to put an n, because this is the number of movies streamed. Number of movies streamed. So what's a reasonable number here for number of movies streamed in a year? It really depends on who you are, but here's where you just have to use some common sense and think, okay, I'm not going to count by ones. I'm not going to say, a total of say 10. 10 movies, I think some of you could probably watch in 1 weekend, never mind in 1 year. So let's count by 5s. I'm going to label every second one here. And this probably still is low when we're thinking of how many movies we might stream in a year or watch. 50 and 60. So that's number of movies. So I've got 60, probably it's way more than that. Now let's look at the vertical axis. I'm going to put at the top here a capital C. It's not a y-axis, it's a cost axis. So I'll label that cost here on the side. Now what scale am I going to use? So remember what I've told you before, you take a look at the last number you put in your x-axis, which is a 60, and you sub it into your equation. Now we have two equations here. It doesn't matter which one you sub it into. If I subbed it into my first equation, c equals 2.5n. So 2.5, I'm subbing in my last number there, which is a 60. So 2.5 times 60, that's going to tell me kind of how high I need to get to. I got 150. So I need to get up to 150 here. So what am I going to count by? Can I count by tens? 10, 20, 30, 40. No, I can't count by tens. I can definitely count by 20s. If I wanted to show off, I could count by 15s, but we'll count by 20s here. So, and I'll label every one. Whoops, that's a bit too high. I'm going to label every one of these by 20s. So I had to erase my writing that I had there so I could fit it in. So I have room to spare here. When you're graphing yourself on your own grid paper, of course, you can have a lot more flexibility with the scale that you use. But you know that on a quiz or a test, I'm going to provide you with a little grid like this, and you just need to make sure that you're fitting everything in reasonably. Okay, so we've got, that's really a major piece. If you spend some time to get good axes going here, then the graphing will be easy. And that's what we're on here. We're on part B, and it says graph both equations on the same set of axes. So we've got our axes ready, and it says using the slope y-intercept method. So the other method that you could use, if it didn't tell you which one to use, would be the table values, right? Table values would be, you'd put your n here, you would put your equation here, 2.5n, you'd maybe pick some numbers and sub them in here, 20, 30, and you would get some values in here, and you would graph them. But we're going to graph this using the slope y-intercept method, which is faster as long as we're pretty good at this, which we should be by now. So I'll start with the first one. So let me just put, I'm going to write the equation again here, the blue one, 2.5n. So the steps, I'm going to put that little invisible 0 back out here again. So remember we had that 0 there. So the steps for graphing, your first step is to graph your y-intercept. That's first. So my y-intercept is a 0. This is direct variation. So I'm going to put a dot right there at the origin. That's my y-intercept. Then my second step is to graph the slope, which is 2.5. Now, how do I graph a slope of 2.5? So I'll just write this down here for now. If I have a slope of 2.5, that really means 2.5 over 1. That means a rise of 2.5 and a run of 1. Now that's really hard for me with my scale I picked of my y-axis scale. My cost is counting by 20s. So I want to make that easier for me. So I'm going to take this 2.5 and I'm going to multiply it by 20. Multiply it by 20. I could multiply it by 10 as well, or by 5, but I'm going to multiply it by 20 and then see if I have numbers that are a little better for me to work with. Remember, I have to multiply top and bottom by 20. That's going to give me 50 over 20. So 50 over 20 is exactly the same as 2.5 over 1, but it's a lot easier to count. So I'm going to count out a rise of 50 and a run of 20 with my blue pen. So I'm going from 0, 0, my y-intercept, and I'm rising 50 and running 20, and that's a lot easier for me to graph. And even though to rise 50 is a little bit of an estimate there, I'm not completely on the grid lines where they intersect, so it's pretty good. So that is counting out my slope, and now I just draw a line, and I will try that with my ruler to draw a line connecting these two dots, and that will be my first line done. So there's my first line, which is okay. I didn't really hit the origin very well, but that's okay. There's my first line. That is movies to go. Movies to go. Now I'm going to put film streamers on there. So film streamers, let me write it up here. Film streamers, so actually I'll put it right here on the 10th. The first thing I want to do is, this is first, I want to graph my y-intercept of 10. So putting a dot there on where I think 10 would be, right about there, my y-intercept of 10. Then the second thing I'm going to do is graph my slope, count out my slope. So I'm counting out my slope from there. So my slope, whoops, I'll go with red here. My slope is 2. That's a rise of 2 and a run of 1. Again, really hard to do with the scale I have here. Since I'm counting by numbers that are bigger than that, I'm just going to continue and I'm going to multiply by 20 again. You could pick anything, right? You could pick tens or something, but if you pick the value that you're counting by in your scale, then at least you'll be able to hit one of the numbers okay. So I'm going to rise, 40 and run 20. So from my red dot, that's already on the y-axis, from my red dot, I'm going to rise 40, and remember I'm counting by 20, so I'm going to go up, rise 40, from 10, that takes me to 50, and I'm going to run 20, and that takes me right here, which is again, I shouldn't have picked multiply by 20 because I just landed right on my blue line, and the whole point of this lesson is for you to have to guess at the point of intersection. But I really don't feel like recording this all again. So I'm going to draw a line between these two red dots. Well, my line didn't work out very well anyway, so it should have, but this is film streamers. Part B is saying, can you see where they cross? I know where they were supposed to cross, but let's just pretend I didn't. So let's just pretend this is the point of intersection right here, and I didn't actually happen to hit it right at the point of intersection. So that looks like the point of intersection because I couldn't graph it properly. So maybe I'm going to guess that that's 15 and, I don't know, 40. No, it's not quite that. 39, something like that. So if you just had a graph, that would be what you do. This is your point of intersection. It would be where it looks like your graph crosses. Now we actually know where it crosses because of the change I made in the scale so that we could graph it properly. But let's erase all of this. Pretend this was never here. And look back at part B. Part B says, can you see where they cross? So let's just put down our supposition here. We're going to say that the point of intersection is 1539, because really when I look at my lines, that's what it looks like where they do cross. That's where they look like they cross. But now I'm going to solve the system algebraically. So here is the best way to do this question, algebraically, going all the way back to algebra. So the algebraic method is great because it's going to be exactly right. None of this looking at my graph and guessing and trying to get some slopes that maybe are going to count out some slopes that I can count with on my graph. None of that stuff. So what you need to understand here is a little bit of theory. Looking up at the original two equations, let me erase this extra stuff in black I have here. So looking up at my original two equations, get my laser pointer, I've got the cost is 2.5n and the cost is 2n plus 10, two different equations, right? So we know that they're going to cross once because the slopes are different. So we know they should be crossing once. Now when we look at the graph, we took a guess at where we thought they might be crossing. When you're talking about a graph where they cross, where our blue line and our red line intersect, that at that point right there that I wrote in purple, that is the one point that both lines share, the only one. This is the only coordinate that these two lines have in common. They're equal right here and only here. So algebraically, I want to know where the equations are equal to each other, not the lines with the equations. So when they're equal to each other, that means the C value should be equal. In this case, my C value was 39, and the N's should be equal. So algebraically, I want my C's to be equal and my N's to be equal. So the way I do that, if my C's are equal to each other, I'm going to take my first equation, which was 2.5n. I'm ignoring the C, just the 2.5n. Now, I'm looking for where that's equal to the red equation, 2n plus 10. And the reason I can do that is because on the left side, they both have C's there. So I'm looking for where these two C's are equal to each other. So this is all I have to do. Now I subtract 2. Now I'm going back to like unit 1 and 2. Subtracting 2n from both sides, we get 0.5n equals, these are gone, so equals 10. Now we're going to divide both sides by 0.5, divide both sides by 0.5, and 10 divided by 0.5 is 10 times 2, that's 20. So that means when our n is equal to 20, our graphs should intersect. So right down here, when our n is equal to 20, which is what we had there, when our n is equal to 20, that is where our graphs should intersect each other. So we know the number of movies is 20, now we have to find the cost. So we sub n equals 20 into either equation. It doesn't matter which equation you sub into. And EQ apostrophe n is short for equation. So I'm going to sub into the first equation, the movies to go. That was C equals 2.5n. So I'm going to sub my 20 in for n, and I get C equals 2.5 times 20, which is 50. So this tells me, therefore, my point of intersection is 2050, and I know that conclusively without having to guess and look at my graph and wonder where it could be. Solving it algebraically tells me exactly where it is. So this is your really important first step that you understand here. When solving algebraically, you want your two equations to equal each other. Just like here, we were looking for where our two lines were equal to each other. Part D says, what is the point of intersection? And what does it represent or mean? So we already said what the point of intersection was. Point of intersection is, I'll put it again, 2050. And what does it mean? Well, remember that the 20 is the N and the 50 is the C. And I erased my sentences up there, but N represented the number of movies. So that means when we stream 20 movies, when we stream 20 movies with either company, the cost will be equal, it'll be $50. So whether I am going with Movies to Go or film streamers, once I have streamed 20 movies, I'm paying the same at both. When 20 movies are streamed with either company, the cost will be $50, and that's over a whole year, remember. So that only at that one point are they equal. Only when 20 movies are streamed, then it wouldn't have mattered which company you went with when you first started your year membership. If you knew you were going to watch 20 movies, it wouldn't matter. Pick either one. But that's the only place they're equal to each other. That's it. One point of intersection. Every place else, they're different. Look at the lines. They intersect once. Let me erase this circle here and some of this stuff here. Okay, they only intersect once. They don't intersect anywhere else. So the last question for this example says, what advice would you give to someone who's deciding which company to use? So if the person knew I'm only going to watch 20 movies a year, okay, then you can tell them it doesn't matter which company. But if they watch more than 20 movies per year, which is probably everyone I'm talking to right here, if they stream more than 20 movies per year, which company is better? Look at the graph here. If they stream 30 movies, 40, 50, 60, which company is better? And in this case, better means cheaper, right? I want to pay the least amount. So notice how after the point of intersection, the blue line is higher. So if we were looking at 40 movies, if you're going to stream 40 movies a year, film streamers, you'd be paying about $80. And for 40 movies to go, you're paying more than that. You're up at 90 something. So if someone's deciding which company to use, if they're watching more than 20 movies, they should go with the lower line because it's cheaper, film streamers. But if they're watching fewer movies, if they're only watching 5 movies a year, then the lower line here is the blue one. So they always switch after the point of intersection. Whichever one was cheaper becomes the more expensive at the point of intersection. So if they're watching less than 20 movies per year, well, then they're going to pick the blue line because it's lower. They're going to pick movies to go. So I'm not going to write down the answer here because I just explained the whole thing, but I want you to press pause and I want you to back it up if you need to and answer this part. What advice would you give to someone who's deciding which company to use? Now, it would depend if they're going to watch more or less than 20 movies per year. But remember, you want to recommend the cheaper company. So press pause and do that, and then we will go on to example 3. Example 3. Solve this linear system and verify your answer. Okay, remember what system means? I told you that on the very first screen. A system means more than one line, which is everything we've been doing. That's a linear system. Here's an equation in standard form. Here's an equation, or they're both in standard form actually. So I want to solve them, and I'm not going to graph them to solve them because I have all kinds of trouble trying to graph and solve and everything. So I'm going to solve these algebraically. What should I do first? Well, first thing I want to do is put it in y equals mx plus b form. If you think of the example we just did, we had a c value here, and we need to have one variable isolated like that. So I'm going to put them both in y equals mx plus b form. So we'll start with the first one. I'm going to do 2 steps at once. I'm going to subtract 2 from both sides, and I'm going to subtract x from both sides. Subtract x, kind of crowded there. So I'm left with 2y equals, and so this is gone, and this is gone, and I'm going to put my x first, so I have negative x minus 2. Now I divide both sides by 2, so I'm going to divide each piece by 2 separately. That gives me y equals, and I'm going to change this to negative 1/2 x minus 1. That's one equation. Now I'll switch colors, and how about green? This one looks easier if I just bring the y over. If I bring the y over, I'll have x plus 11 equals y. So now y is isolated. It's in y equals mx plus b form. It just doesn't look like it. I can pick up a y and an equal sign and move it, and then I don't have to change any signs. Y equals x plus 11. So the theory behind that is if I said 27 equals y, that's the same as saying y equals 27. These two are the same. So I don't have to make anything negative if I'm picking up the equal sign along with the y. So these two equations are now set up into y equals mx plus b form. Step 2, set the equations equal to each other. So now that I have the y isolated, I can write out the right-hand side, which is I've got a negative 1/2 x minus 1, and I'm going to make that equal to the other side, which is x plus 11. So these both have a y in them, which means, and since I'm looking for the solution means the point of intersection. Since I'm looking for the point of intersection, I want the y's to equal each other, so that's why I'm allowed to do this step here. So set the equations equal to each other. Now what? Isolate x. Okay, so let's first start by collecting like terms. I'm going to add x to this side and add x to this side. I won't skip any steps here. That gives me, what's negative 1/2 plus 1, or 1 minus 1/2? It's 1/2 x. So I have 1/2 x minus 1 equals, oops, that's subtract x. Subtract x there. Wow, that was a big mistake. Subtract x. Subtract x. See, you guys were telling me that with your minds. That's how I picked up on that mistake. So this is negative 1/2 minus x is 3/2. If I'm skipping too many steps there, then you need to go and work with your fractions, right? Go off to the side. Okay, you have negative 1/2 x minus x. That's really negative 1/2 x minus 2/2x. That's negative 3/2x minus 1. These are gone, equals 11. Next step, the constants. I'm going to add 1. That time I got it right. Negative 3 over 2x equals 12. Okay, now I have to divide both sides by negative 3 over 2, and here's where I sometimes lose some of you guys, so let me do this slowly. These will be gone because they cancel it to 1. I'm going to have x equals negative 12 divided by negative 3 over 2. I'm writing it like this on purpose because I want to change my division to multiplication and flip this over. You can leave the negative on the top though. 2 over 3. And this is really 12 over 1. So again, review your fractions if you need to. That's going to give me 24 over 3, and 24 over 3. Wow, see, it's getting late here. This is not, that's a negative 12. Oops, sorry. Negative 24 over 3. I'm just going to skip ahead and reduce that myself. And if I've lost you, you're going to have to go back and review your fractions. That's a negative 8. Okay, and again, you can cancel here, divide this by 3, divide this by 3. So x is negative 8. That's step 3. That's a lot of work, so it feels like I'm done because I isolated x. That's great. Am I not done? Well, look at the question. The original question said solve the linear system, and I wrote underneath it that solve means find the point of intersection. All I found is an x value of negative 8, and a solution should look like negative 8 and then some y value. But I don't have that y value yet, so I'm not done. So step 4, we have to go back and find y. So to go back and find y, I pick one of the two equations from up here, whichever equation I like better. Always up to the original, never back to these because I could have made a mistake there, and I've already made some mistakes today. So I'm not going to go to those. I'm going to go back up to my original equations, and I'm going to pick whatever one I think is easier to work with. I'm going to pick the one on the right, the one with the green. So I'm going to sub in, I'll write it out again, x minus y plus 11 equals 0. I've got an x value of negative 8. Negative 8 minus y plus 11 equals 0. I'm going to add y to both sides. And I have negative 8 plus 11 equals y. So negative 8 plus 11 is 3. Now I can put this in here. I now know what my x value is supposed to be, or my y value. I figured that one out. So step 5 is to state the coordinate. Therefore, the point of intersection, which is the solution, is negative 8, 3. Are we done? It feels like we should be done. This is a long lesson, right? No, we're not done. Check. We have to verify our answer. So to verify our answer, we sub in our x and y. This goes in for x and this goes into y, and I sub it into each of my original ones. So I want you to press pause here. I'm going to press pause and I'm going to write it all out. When you come back, the answer is going to be here. So I want you to check. You're going to do a little table like this with your left side. So for my first one, actually I should use red here. My first one is x plus 2y plus 2, and my right side is a 0. That's really easy. But now I'm going to sub this in to see if I get it to balance. So press pause and finish that for both equations. So hopefully you did that yourself and you got everything to balance, left side and right side. They both happen to equal 0. They don't need to, both pairs don't have to equal the same thing. So as long as you have these both equal 0, now these could both equal 500, it doesn't matter. But these two have to, the left side and the right side have to equal each other. So that's your check. That proves that negative 8, 3, that point is on the red line, and it proves that negative 8, 3 is on the green line. Therefore, it's on both lines, so it must be the point of intersection because it's on both lines. That's all that it can be. So we're done. I'm just going to show you graphically. I put this on Desmos. and just there's the original first equation is red and the other one is blue, and graphing with Desmos shows you there's a point of intersection. We didn't have to solve this one by graphing, but you can always check if you want to pull up Desmos anytime you're doing your homework. You can just type your equations in and you'll see that it's right. Sometimes you think the back of the book must be wrong because I'm not getting that answer. Well, Desmos is a great way to check. So that was a long lesson, and linear systems is a very important one. It brings everything together from a lot of Unit 3 and Unit 4. So please be sure to go through all the homework and do lots of practice.